When most people imagine the future, they picture it unfolding step by step, like a straight line. But that's not how technology evolves. The story of innovation is exponential. It doubles, compounds, and accelerates, leaving behind anyone who expects a slow crawl forward. This is the heart of what's called the law of accelerating returns. The principle is simple: progress builds on progress. Every breakthrough creates the tools for the next one. Each generation of technology doesn't just add to what came before it, it multiplies it. Take computation as an example. We've gone from electromechanical relays to vacuum tubes to transistors to microchips. Each stage solved the limitations of the last, while also setting the stage for explosive growth. Every time a ceiling appeared, a new platform emerged to keep the curve climbing. The best known illustration is Moore's Law. Since the mid 20th century, the number of transistors that can fit on a chip has roughly doubled every 2 years. That doubling meant that the computer in your pocket today is millions of times faster and cheaper than the supercomputers of a few decades ago. But Moore's Law is just one chapter in a much bigger story. Exponential growth doesn't belong to one technology. It's a pattern that applies to many fields at once. When one area slows down, another rises up to continue the exponential trend. The law of accelerating returns explains why technology never hits a permanent plateau. This acceleration follows a familiar life cycle. At first, progress is slow. A new idea feels clunky, expensive, and impractical. Then suddenly, the curve bends upward. Improvements come rapidly. Adoption explodes, and industries transform. Eventually, the growth slows as the technology matures. But just as it plateaus, a fresh paradigm takes over and starts the curve again. You can think of this like a relay race of innovation. Each technology runs its stretch, then hands the baton to the next. That's why progress never truly levels off. The relay keeps going with each runner faster than the last. This is exactly what's happening with artificial intelligence today. After decades of research, the field entered its explosive growth phase. Hardware improvements, massive datasets, and breakthroughs in algorithms all fuel one another. Each advance multiplies the effect of the others, pushing AI forward at a pace that seems almost unnatural. The problem is that human intuition isn't wired for this kind of growth. Our brains evolved to think linearly. If you walk 30 linear steps, you cover 30 meters. But if you take 30 exponential steps, doubling each time, you end up more than a billion meters away. That's the difference between how we think progress should feel and how it actually unfolds. This mismatch is why experts often underestimate the future. Predictions based on straight lines always fall short because they fail to account for the curve. As a result, changes seem to arrive out of nowhere, when in fact, they were compounding all along. Look at the internet. In the mid-1980s, it had only tens of thousands of servers. Many experts doubted it would ever amount to much. But they were thinking linearly. In reality, the network was doubling in size every year. By the mid-1990s, it had tens of millions of nodes. The exponential growth was invisible at first, then unstoppable. AI is on that same trajectory. At first, it looked slow and underwhelming, programs that could barely play chess or recognize speech. Now, just a short time later, it's creating art, writing code, and driving cars. And this is only the beginning. The key takeaway is this: exponential growth means the future won't look like an extension of today. It will feel like a rupture, a sudden break from what we thought was possible. The coming decades won't bring a century's worth of progress. They'll bring tens of thousands of years of advancement compressed into a single lifetime. That's why understanding the law of accelerating returns is so critical. If we keep thinking linearly, the future will blindside us. But if we think exponentially, we can start to grasp just how quickly AI and other technologies are reshaping the world.